based on few concept. Okay. See, in mechanical properties of solids, you may expect some questions for 1 mark, and some question they may ask for 2 mark, and so maximum 3 to 4 marks they may ask in annual examination. Okay, 3 marks or 4 mark. Okay, so maximum you can expect some, okay, problems based on some concept. Okay, we will discuss that problem later. Let me to discuss a few things, okay, the very basic things in this chapter. So remember, in this case, so mechanical properties of solids, what it means, mechanical properties of solids. So you are already familiar with these things, that is solid, right? So different states of matter you already studied, isn't it? So what is that? Solid, liquid, gases, you already know the characteristics of those, isn't it? So in solid, we already know. So atoms or molecules which are closely, okay, so they are tightly bounded. Okay, so like that. Okay, so tightly bounded. So in other words, we can say rigid body. So let me to explain first rigid body. To understand this phenomenon, you must know what do you mean by rigid body. Can anyone can you define how can I define this rigid body? Anyone, can you tell me what it means, rigid body? How can I define this? Yes, you know these things, right? So rigid body means what? It has a body, it has definite shape and size, which has definite shape and size, isn't it? Okay, so that type of body is called a rigid body, which has definite shape. So one particular shape is there, one particular size is there. So that type of body is called rigid body, we can say. So example, can you tell me example? Yes, metals. Yes, isn't it? Which has definite shape and size in this, remember, so atoms or molecules which are tightly bounded, they are compact in nature. Okay, they are very tightly bounded. So due to this arrangement only, okay, we can say, yes, it has definite shape and size. Okay, hope you understood. A rigid body, a body, it has definite shape and size. Okay, so for example, iron rod. Now tell me, this is a rigid body. For a moment, we can consider it is a rigid body. Why? Because it has definite shape as well as size. So it means, see, in this case, it has particular length, it has, right, and particular diameter is there, isn't it? So, and also which is made up of some materials. Okay, definite shape is there, size is there. It means from all these characteristics you can consider the given body is what? Rigid. A given body, it is considered as what? Rigid. But remember, for a moment we can consider these things. For a moment I can consider this body is rigid. How? Yes, question may arise in your mind why it is. So for example, so for a moment we can consider rigid body. But once I apply a temperature, once I apply a high temperature for this iron rod, then what will happen to this iron rod? Just tell me, what will happen to this iron rod? What will happen? Yes, anybody? Yes, 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 good, good. So someone is giving answer. So what will happen? Its state will change. Okay, so state will changes. Due to high temperature, it start to what? Change its state. Yes, good, good, Anup. Yes, good. So it means, just tell me, you can say a rigid property, you can say for some extent. Okay, for some extent we can say rigid property. But Perfect rigid body, you can't say this one. Okay, iron rod we can say rigid body, but perfectly rigid body I can't say for a moment. Okay, so it is just because of these things. Okay, hope you understood. Okay, so remember we already discussed rigid body and perfectly rigid body. Let's consider a mechanical properties of solids. What it means mechanical or mechanics, which is related to what? Which is related to motion, right? Which is related to motion. So in this particular chapter, why they called mechanical properties of solids? Why it is? So mechanical properties of solids means, so motion of the atom, or you can say motion of the molecules. We have to study in this chapter, in entire this chapter we are going to study about the motion, the behavior. Okay, behavior of the atom, or you can say behavior of the molecule after applying a force. After applying a force, how it behaves after applying a force, a external force. Okay, yes, good. Okay, so remember in this case, mechanical properties of solid. So what will happen to understand this concept? Let me to tell like this. So for example, take a one body, so which is made up of okay, sponge. Yes, so it has definite shape and size, you can say. Yes, so it has definite shape and size, which is made up of sponge. So once I applied a force on it, once I applied a force, now I am applying a force on it, then what will happens to this sponge? What will happens? Of course, what will happens? The shape as well as size will be changes. Yes, good, good, good. It start to compress, right? It means, remember, in this case, so this body will start to compress in this way. So now it is compressing in this way. Just remember, now its size will be reduced. It start to compress. See, isn't it? What will happen exactly in this case? Now we have to study that matter in this particular chapter. What will happen after applying a force? How it behaves? How this body will behave for this force? So we are going to study these characteristics in this particular, okay, chapter. Yes, good, good. Someone is telling, yes, molecules comes closer. Yes, it loses its shape and size. Good, good. Same thing will happen, students. Okay. So once I apply a force on sponge body, then what will happen? Sponge will get compressed. So due to this, what will happen? The shape and size will be goes on decreases. It means, remember, so what exactly happens in this case? Let me to explain in this way. So in your book, they given one model that is called spring ball model. So that is called spring ball model. So this is very good example to understand this. What is that? See, in this case, we have to use a ball in this way, okay, in this way. So this is a 3-dimension, okay. Then we have to consider in this case spring instead of, okay, these sides we have to connect spring between each molecules. We have to consider spring like this. Just imagine, this is a, okay, very good example to understand. Yes, okay, roughly I, okay, drawn this. Okay, just go through your textbook to come to know that, okay, what exactly it is. Okay, see, so two molecules which are, okay, binded with the help of spring. This is spring now. Yes, Now remember students, once I applied a force on this, okay, spring ball model, what will happens to this model? What will happens? What will happens? Yes, it will start to compress. It start to compress. It means immediately its shape as well as size will be goes on change. Hope you understood. Yes, correct. Compression will happen. So remember what exactly happens in this case. Shape and size is changing means the interatomic distance, or you can say the molecular distance between two molecules. Molecular distance between two molecules will changes. How it is? Let's see. In this way. So for example, any solid material if I consider, okay, any solid material if I consider, which is made up of number of, okay, molecules or atoms you can say, okay, which is tightly, okay, bounded in this way. Yes, once I applied a force, then interatomic distance, or you can say molecular distance between two molecules, see, an interatomic distance will change. So for example, initially this is the distance between two atoms or two molecules you can say, okay. Then once I applied a force, then what will happen? Due to that force, what will happen? The distance, the interatomic distance, or you can say the molecular distance between these two molecules will goes on changes, goes on reduces. Due to this only, the shape as well as the size will changes. Hope you understood. Yes, good. Someone is telling, okay, Prithvi Hegde, good. Okay, one molecule applies a force on another and it changes. Yes, good. Why? Because there will be an intermolecular force between each atoms. So this atom will exert a force on this, as well as this atom also exerts a force on this. So there will be a force between two atoms, or you can say there will be a force between two molecules inside the body. You can't see this one. This is happens inside the body. Hope you understood. So this is internal force, what I'm telling. Okay. So it means once I applied a force on a body, then what will happen? Due to that external force, the interatomic distance will changes. Due to that, that body will lost its original shape as well as, okay, size. Okay. Original shape and size. Okay. This is happens in this case. Okay. Yes. Then let me to explain two more things, very important things. So first one, we can say, first one, deformed force. You may expect this question in Viva, in practical examination. So second one is deforming force. What it means? Deformed body, and one more is deforming force. How can I define these two things? Yes, can you tell me anyone? So as I explained earlier, see, any solid material, take it as a sponge. Okay, once I applied a force, so it changes its, okay, shape as well as size. Correct? It means a force which is used to change the shape as well as size of the body. Just try to understand. Yes, just try to understand. A force which is used to change its shape as well as size of that particular body, that force itself is called deforming force. What is that? Deforming force. And the changed body, a changed body, okay, after applying a force, so it will gives you new shape as well as size. So this body, okay, this body itself is called deformed body. So hope you understood. Hope you understood, students. Just tell me whether you understood or not. Otherwise, let me to explain once again. Yes, these are basic things what I'm going to explain. Yes, yes, just interact with me. Yes, okay, okay. Shall I move to next concept? Yes, okay. See, deforming force. Once again, let me to explain. Deformed body means after applying a external force, the body will changes its shape as well as size. The changed body itself is called deformed body. It is already changed. Okay, that is called deformed body. Then one more is deforming force. Deforming force means a force which is responsible to change its shape as well as size. A force is responsible for what? To change its shape and size. So that is called, okay, that force itself is called deforming force. Hope you understood now. Hope you understood. This is external force. Okay. So once I apply a external force, the body will changes its shape as well as size. Yes, I will give you notes. Don't worry. Don't worry. Okay. I will give you notes. Okay. Just try to understand the concept first. Okay. Notes is not a big thing. Okay. Just try to understand. So deformed body and deforming force. Okay. Hope you understood. Yes. Yes. See, someone is asking actionable force and one more is restoring, deforming force, whether it is same or not. Remember, this is external force. Yeah, you can, for a moment, you can treat it as what? Deforming force. Why? Because that force is responsible to change its shape. Okay. So that force itself is called deforming force. Okay. Yes. Now, let's see one more concept, the very important concept in this chapter. Remember, in mechanical properties of solid, it includes, okay, three concepts. The very important, first one is elasticity. First one is elasticity, and second one is plasticity, and third one is called ductility. Yes. Anyone can you tell me how can I define these three things? Anyone? Yes. 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 Good. Good. Yes. Adarsh. Correct. Correct. See, it includes three concepts. So first one is elasticity, second one is plasticity, third one is ductility. How can I define these three things? Remember, elasticity. So let me to give some example for elasticity. Okay. See, so this is a rubber, isn't it? Hope you and you can understood. Yes, someone asking. Yes. Yes, good, good, good. Correct, correct, correct. So someone is telling, okay, elasticity definition, that is 100% correct. Okay. See, let me to explain once again. You know everything, these, okay, this concept. Yes, just try to understand. See, this is the rubber. So see, this is the original shape and size of that particular rubber, right? So this is the particular length. Yes. So for example, once I applied a force, now I am applying a force on this particular rubber. Okay. See, once I applied a force, yes, 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 yes. See, so it changes its shape, size, length, right? See here. Yes. So once I remove a force, once I remove an external force. See, once I remove this, then what will happen to this rubber? What will happen? Yes, rubber will regains its original shape as well as size. Correct. Good, good. Someone. Yes, 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 yes. Correct, correct. Some, yes. All are giving answer. Just interact with me, okay? So I hope you understood all these things. Okay. Yes. See, once I remove a force, rubber will, okay, regains its original shape, original position, its original shape as well as size. It means, how can I define this? It is a property or a tendency of a body which regains its original shape and size or original position after removal of what? An external force. After removal of what? External force. So that property itself is called what? How can I define this? Elasticity. Elasticity. Remember, students. Okay. So let me to explain. Let me to tell definition one more time. Okay. It is a property of a body which regains its shape and size. Okay. After removal of, okay, external force. Yes, correct, correct. That is called elasticity. Then one more is plasticity, just the reverse of this. Just reverse of this. How can I define them? A body which do not regains its original shape and size, even if we remove an external force. Yes, good, good, good. Yes. So that is called plasticity. How can I define then ductility? How can I define ductility? Yes, it has tendency to, okay? Yes, yes, correct, correct. It means, so for example, if I consider gold and silver, so this is a gold plate. I can turn this gold plate into thin wires. See, I can turn into what? Thin wires, a negligible, okay, thickness, a thin, very thin wires. So this property itself is called ductility. Yes, remember, mechanical properties of solid, any solid material which has three, okay, concept, that is, one is elasticity, plasticity and ductility. Hope you understood these things. Hope you understood. Hope you understood. Shall I move to next concept? Shall I move to next concept? Yes, yes. Okay. Yes, someone, Suraj. Suraj, why are you late? Okay. Yes. Okay. Let me to explain one more concept in this chapter. So very important. These all are basic things what I explained until now. Okay. So actually the topic will be starts now. So the very important, okay, concept, that is stress, strain, the different types of stress, different types of strain. So let's see one by one. First one is stress. I hope you know by heard this word, okay, stress. Stress means what? How can I define stress? I hope you know this pressure. Pressure is nothing but force by area, correct? Force by area, that is called pressure, isn't it? So in the same way, stress can be defined as, okay, let me to write in simple way, it is the ratio of restoring force per unit area. What is that? It is the ratio of restoring force per unit area, that is called stress. Yes. Then remember what I written earlier, pressure and stress. But both are same for a moment. But the way of, okay, we are using in different situation in different words. Okay, so in mechanical properties of solid we are using here stress only. Okay, stress means restoring force by unit area. Then question may arises in your mind, what is this restoring force? Nothing is there, students. I will tell you in simple way. Just remember, just take a rubber ball which is made up of rubber. Okay, once I applied a force, once I applied a force, once I applied an external force, some force if I applied, then what will happens to this rubber ball? So this rubber ball will, okay, gets compressed. Okay, it changes its shape as well as, okay, size. So see, in this way it looks like this much compression will be there. So small minute compression will be there. Okay, so it is just because of presence of external force. So I already told you in spring ball model, once we applied a force, once we applied an external force on any body, then what will happens? What will happens? Due to that external force, so whatever atoms or molecule is there inside that particular body, that gets what? Disturbed. That get disturbed from their mean position. It means from its original position. It will move, or you can say in this way, so that particular atoms or molecule get displaced from their mean position to some other position. So in this way, okay, when it moves from its initial position to some other position, so it will start to compress. Okay, so due to the variation in the interatomic distance or molecular distance, so shape will be goes on reduces. Okay, hope you understood in this way. So we already know, once I applied a force due to an interatomic distance, the force will be exerted. Someone is telling yes, 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 yes. There will be a force between each atoms, or you can say each molecules. Okay, so this atoms will exert, this atom will exert a force on this. Okay, as well as this atom also exerts a force on this. It means the force will be developed between two atoms, or you can say the force will be developed between two molecules. The sum of all these forces are nothing but what? Intermolecular force. Intermolecular force. Remember, inside the body, okay, one more force will be developed. That force is called what? Interatomic forces, or you can say internal force. Internal force. But remember, this force is always opposite to external force, or you can say applied force. So these two forces are equal in magnitude. But remember, one more important things I have to mention here, the applied force and intermolecular force. So for example, I am applying here 50 Newton means, okay, inside the body, due to that atoms or due to that molecules, all molecules, okay, it will generate some force. That force itself is called intermolecular force or interatomic force, or we can say internal force. That force also develops 50 Newton only. They are equal in magnitude but opposite in direction. Remember, they are equal in magnitude but opposite in direction. Hope you understood. So remember, in this case, what will happen further? Then restoring force. How can I define this restoring force? So this restoring force is, okay, responsible to take a body to its original position. To take that particular body to its original position. That type of force is called restoring. So which is stored inside the body, okay, which will generate inside the body. So that's why we can call it as restoring force. Hope you understood. Yes, good, good. Someone is telling. Yes, yes, correct, correct. Hope you understood these things. Restoring force. Hope you understood. Yes. Hope you understood restoring force. Okay. Yes. Remember, let me to explain. Still, students are joining. So why they late? I don't know. Yes, let it be. Yes. See, once I applied a force due to, okay, intermolecular distance will varies. So due to that, what will happens, the body will get compressed, the body will change its shape and size. So in this case, the applied force as well as what internal force, both are equal in magnitude but opposite in directions. Okay, so but a force which is responsible to take that particular body to its original position, that force itself is called what? A restoring force. Restoring. Okay, why? Because this is stored inside the body only, inside the body. See, how can I mention the SI unit here? Anyone, can you tell me how can I write SI unit for this particular quantity? Yes, stress. We already know, for a force we can write Newton divided by area is nothing but what? Area, that is meter square. So together we can call it as Newton per meter square. Hope you understood. Newton per meter square. Okay, then different types of stress. Let me to write different types. Okay, stress. Yes, I will give you notes, don't worry. Okay, students, just go through your textbook, just read once. If you have any doubt, feel free to ask. Okay. Yes, types of stress. So first one, the very important, that is, remember these things you must remember. Why? Because some problems will arise. Okay, some problems will comes based on this concept. Okay, so first one is longitudinal stress. In this there are two types. Okay, let's see that one. So first one is tensile stress and compressive stress. Second one, tangential stress. Third one, okay, bulk stress, or we can say volume stress also. Okay, let it be. Okay, let me to explain one by one. So hope you understood